Hi guys, scientific notation. I know you hate it, but I'm pretty convinced the reason why you hate it is because you don't use it very often. So before we start getting into the mole where we have to use the number 6.02 times 10 to the 23rd a lot, let's just do some just basic ones just to kind of get you back into kind of what scientific notation is. First of all, why do we have to use it? Why do we use it? Why do we learn it? It's for very big numbers, okay? So when we have very big numbers, and then we'll talk about later about very small numbers, it's just easier so we don't have to write all the zeros. So let's look at this first example I have. World population. In August 2016 was estimated to be, oh wow, that's a big number. I don't even know how many zeros that is. I mean, I'm sure it's a billion, a trillion, or something like that. But let's just get in scientific notation so we don't have to worry about it. So, remember when scientific notation, we always want it so that we have one number in the one spot. And then we go out to the tenths and hundredths. Okay, that's just standard notation. That's how we write it. And so now we have the factor of, that's the times 10 to the, not just the factor of 10. And that's just dependent on how many places you have to move the decimal point from the original number, which is this, to the standard, to the scientific notation number. So how many times did you have to move that decimal point? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's why it's 7.40 times 10 to the 9th. And we're talking about people. That many people in August. Okay, so let's go back to more of my day, kind of back around the time when I was born. We're going to take that, the population was halved. All right, so we need to divide by 2, but sometimes students get confused. What do I divide by? Do I need to worry about this right here when I'm dividing? Not really. No, what you're going to do when you divide by 2 is you're going to take your original number, 47.40 times 10 to the 9th. Yeah, we're going to divide it by 2, but you're going to only divide the front number. So that would be 7.40 divided by 2, which equals 3.70. Now we can't forget about that. We have to pull it over times 10 to the 9th. Okay, so that's how many people there, approximately how many people there were around 1975. Now, next one, if the population doubles to 2073, which is expected to do, how many people are going to be on the planet then? Well, we'll take our original number here, and this time we have to double it. So we're going to, again, take 7.40 times 10 to the 9th, and we're going to double that. Same thing, you multiply the front number by 2, right here. Okay, and you get something like, so you can just do that with a regular calculator. So 2 times 7.40, that would be 14.8. Now we carry the times 10 to the 9th, the factor. But wait, that's not in standard scientific notation, so let's make it right. And if we're going to make it right, that means we are going to move the decimal point over 1 to go 1.48. And we took 14 and made it 1.48. That's reducing it by a factor of 10. If we reduce it by a factor of 10, that means we have to increase our exponent by a factor of 10. So that's how whenever you reduce, then you have to go up 1 on the exponent, and then vice versa in the front number. If you increase it by 10, then that means you have to go down on the exponent. Okay, so let's go ahead and write that number back into standard form. That means we have 148. Our decimal point was right here, correct? But we need to move it over to the right because we're moving to the right because we're making a big number. 10 places. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I need to come back, get rid of that. Oh, that was too much. Okay. And see, this is why I like scientific notation. All those zeros just kind of make my head hurt. I can't remember if it's a million or billion or trillion. Just like scientific notation makes it so much easier. So, okay, by the way, that's a lot of people. I won't be alive then, but you guys will be. So, all right, next step. Why else will we use scientific notations? Very, very small numbers can be represented better this way. Okay, so let's take it back to our original world population, and let's ask, what fraction of Wayne, what do we make up, our high school make up in the entire world's population if we think that there's 1,300 students at Wayne? Well, in this case, again, since we're going to have to do a fraction, and so we're going to take our part, which is Wayne, divided by the total, which is our number from up here. But again, those big numbers. Let's just get them into scientific notation. I'm first going to take 1,300 and put it in scientific notation. So we have 1.30 times 10 to the how many? Yep, that would be 3. That's our part. Now we're going to divide that by the total, which we already said was up here. We already calculated that in scientific notation, so let's put that in. 7.40 times 10 to the 9th. So now we have to divide. Now the two front numbers, you divide just like you normally would. Get out the calculator, divide away, and you get something like 1.76. To do the exponents, we do something where we subtract. When we divide exponents, you subtract. So this would be 3 minus 9. So this is equal to 0.176 times 10 to the negative 6th. Again, is that proper scientific notation? Of course it's not. And so let's put it into regular scientific notation. Again, we're going to move our decimal point over by 1.76. But this time we went from a small number to a big number. So to get the equivalent, we're going to have to reduce our factor of 10. We did have negative 6. Now, what is smaller than negative 6? Is it negative 5 or negative 7? Yeah, it's negative 7. You can think about it getting farther away from the 0 on the number line. It's getting smaller. And so in this case, it's 1.6 times 10 to the negative 7th. Okay, and so question, did I answer this in scientific notation or standard? I wanted to do it in scientific. So let's convert to another. That would be 176. Here's my decimal point, and this means I'm going to shift it to the left. And I'm going to go, here it is, 1, 2, 3, 4, 5, 6, 7. There we go. And come back and erase my decimal point. Put my 1 back. Okay? So that's what we have there. Go away. Go away. Okay. So again, that's kind of the basics in using scientific notation. Going back, just remember, again, when you're doing things when you're dividing, with scientific notation, you subtract. So that was why we did 3 minus 9. Ended up being a negative 6. We had to make this into a bigger number, so that's why we reduced this by a factor of 10. Now, what would we do if we were multiplying two exponents? Like if we had 10 to the 2nd times 10 to the 3rd. Yep, you guessed it. We add them. So this would be 10 to the 5th. And so that's how we would do that. Okay, so hopefully this will give you a good start. I want you to go ahead and work on the rest of the sheet. And some of this is you're going to be dealing with moles. But we're going to see how you do with this, and then we're going to go ahead and then cover it. We'll review it tomorrow when I get back. Have a good day.